Hello and welcome to another video, this time on the Stats October 2021 A2 paper, question 3, and this is under the category of sampling, statistical diagrams and measures. Okay, Stav is studying the large data set for September 2015. This should immediately put you on your guard. It's a large data set. Okay, he codes a variable, daily mean pressure, using the formula y equals x minus 1010. Yeah, so a fairly simple linear code there. The data for all 30 days from Herne are summarised by these summary statistics, and the first thing they want us to do is state the units of the variable x. Well, this is daily mean pressure, and it's actually measured in hectopascals. Now you've got to really know the large data set well for that. I would suggest that most of this occurs on the front page of the paper. You get all of the it will tell you, it's worth basically printing off that front page, that information page in the large data set, and actually having it on your wall so you can slowly get a hang of all the units and things like that. But that's really quite hard. But yeah, it's measured in hectopascals, and I think you would get away with it if you just said Pascal actually. Let's have a look. Let's have a quick look on the mark scheme, see if it would have let you have that. Do not allow pascals on its own. No. Oh, no, sorry. Hectopascal or HPA. Condone pascals. Allow millibars as well. Do not allow kilopascals or just PA. That's what they wouldn't allow. But, they would have allowed pascals written. Okay, so there we go. Find the daily mean pressure for these 30 days. Okay, right, well, we've got to remember that y is the coded data, so if we want to find the daily mean pressure, we will have to think about the linear code at the end. But firstly, let's find the mean. So the mean, let's do the mean, for y. Let's just do y bar. Y bar is just going to be the sum of y over 30. So that's 214 over 30. And that comes to 7.133 reoccurring. But that's the mean for y. At the end, you've got to apply the linear code. We need the mean for x, which will be y bar plus 1010. The mean's really well behaved when it comes to linear codes. You just apply the linear code unthinkingly. So x bar is going to be equal to 7.13 reoccurring plus 1010. And so that's 1017.13 reoccurring. But let's have it to three significant figures. 1020. Well, I don't even really want to round it here. Like, I'm going to keep it as 1017. But yeah, right. If you're ever worried, just say 1020 to 3 sig fig. If you feel like you're losing accuracy, if you've got both answers written down, it seems absolutely reasonable that you would have, and they can mark the right one accordingly. Okay, find the standard deviation. Well, the standard deviation for y is going to be the square root of the sum of y squared over n, which is 30 in this case, minus our previous answer for the y bar, 7.13 reoccurring, squared. Yeah. Now you work that out and you get 12.1. Yeah. Now, do we need to adjust for x? No, we don't. We don't need to add or subtract. That doesn't change how spread out the data is, taking away 1010. So this is the final answer. Yeah, you can say it's a standard deviation for x as well. It's just 12.1. Look up linear coding if that's confusing, but that's how it works. Now, this last part, I've got to be honest with you, I think that's extraordinarily difficult to do without having this map right there in front of you. Now, Stav knows that in the UK, winds circulate in a clockwise direction in a region of high pressure and an anti-clockwise direction around a region of low pressure. This table gives the daily mean pressure for 3 locations, in a large data set. So we've got 1029, 1028 and 1028, yeah. Now, if you look, these are all above the daily mean pressure, 1017. So these must be high pressure, So this must be going in a clockwise direction, Sure enough, Heathrow, Herne, Heathrow, we're coming around to Loikers and Leeming, This is the way the wind's going to be circulating, and we can see that because it's in high pressure. So the cardinal wind direction for these relocations on the 26th were in a random order. You may assume these 3 locations were under single region of pressure, and we've got to use our knowledge of the large data set, or use like the photographic picture we've got in our head of this diagram, place each of these cardinal wind directions in the correct location in the table. So I would guess that Herne to Heathrow, that is kind of east or even northeast. Yeah. So I'm going to put east, north, east for, I'm guessing in Herne it's blowing towards the north east. I'm going to go east actually for Herne. Loikers, I'm going to go west because it's probably going to be going round in that direction from Loikers. And then Heathrow, well, it's certainly, is that going northeast? It's not really. I think I need to switch these round. I think I need to have Herne as northeast and Heathrow as, no, that's, no, I reckon it is that way round actually. Heathrow going up to Loikers is northeast. It could even be west here. It's it's really hard to see, but I guess. Firstly, I don't. This is the funny thing, right? Is this map actually decent? Like, as in, is Loikers to the left of Heathrow? Let's actually have a look. Let's see how poor Edexcel are that they can't even do their own map right. I'm just going to quickly get a Google map of the UK. But I need a decent map here. Is Google going to be good enough? I know that this is the answer they'll accept anyway, so don't worry. But yeah, I'm not convinced anyway. I won't bother doing that, but I'm not convinced that it actually comes up there because it does kind of look like it's going to be blowing. I guess it's going to be blowing in that direction and then that direction later, isn't it? So it's going northeast. So we'll go east from her, northeast, then it starts to come round here. But that's basically. Oh, and give a reason for your answer. So high pressure, so clockwise direction. And then see arrows in my diagram. It's always fine to draw a diagram. But yeah, that question is difficult because you've got to know like latitudinally where the placings are of the cities, and that's really very, very tough. Okay, but there we go. I hope you enjoyed the video. Bye bye.